Hello and welcome everyone. My name is AnimeshSingh. I'm an IBM Distinguished Engineer and CTO for Wotson Data and AI OSS platform. And I'm primarily responsible for driving IBM AI and ML strategy and execution, both externally in open source, working with a lot of open source communities, as well as internally with Wotson, while my focus has been, creating an AI platform, delivering and growing successful AI projects in the open source community, working with the community. And then, also driving their adoption both externally as well as internally. Couple of specific initiatives which I lead. Excuse me. One in external open source community with the Qflow project. So I'm IBM's engagement lead with Qflow. I'm also the Linux Foundation AI Trusted AI North America chair for our Trusted AI initiatives from IBM. Right. I also lead IBM's and Red Hat data and AI OS strategy and execution, and aligning on common open source projects and building reference architectures and solutions and platforms on top of it. We are part of a group in IBM called CODE, Center for Open Source Data and AI Technologies. Mostly a large part of the team is located in Silicon Valley in California, IBM location. And it's a sunny place. If you haven't been here, I would definitely encourage, a lot of greenery around, mountains around, and, majority of the team is located here, but we are spread out globally. In fact, we go to uh, centers across US as well as across globe in terms of the members, participating in open source community projects with us. So here we are going to talk about machine learning and AI. Now, as we talk today, right, I think we probably realize that, machine learning and AI are everywhere, right? And we are using it in our day-to-day lives, right? For example, you are using facial recognition to unlock your phone, or you're using spam detection to remove, unwanted emails from your inbox. There are chat bots, right, when you're doing calls, which are routing your calls. And then, there are autonomous vehicles which are running. Then there are recommendations when you are shopping online, right? So we are using this in our day-to-day lives now at this particular point in time, right? And if you look at the landscape of open source projects across ML and AI, that has just exploded. Almost every domain you can think of in the ML and AI, there is an open source project. And in a lot of cases, right, you will be able to build everything from scratch using open source, obviously, with a lot of responsibility of, bringing them together, making them work cohesively, and maintaining them, right, on an ongoing basis. But this is the Linux Foundation landscape diagram. If anybody is interested, reach out to me. I can send out, links, but keeps on exploding, and you can get much more detailed information about the overall data and AI open source ecosystem. Okay, and so one of the things, though, even though the prevalence of AI is now everywhere, when we are looking at enterprises and most, corporates, a majority of that, close to 90% of the AI initiatives are struggling to move beyond testing stages, right? In a lot of cases, right, there is no quantification of the business impact. In a lot of cases, there are teams which can include and run POCs, but they don't have means to deploy models or deploy AI in production. If they have means to deploy AI in production, they don't have any ways to, collect the relevant metrics, whether the models are doing what they're supposed to be doing in the right way, right? And then, the scaling of the AI, right? So it's not only one model, right? You're going to be producing more and more, deploying more and more, right? So we are seeing, majority of the corporates at this point are struggling with that. And hence, our talk today is going to be focused on this area. Essentially, how do you scale your enterprise AI deployment, enterprise AI creation, but also, how do you do it in a trusted manner, right? When we say in a trusted manner, that means, you're able to create AI which is unbiased, fair, governed, you have right provenance and lineage. It's not vulnerable to adversarial attacks, right? So, and that's, essentially the two core areas where I'm going to be focused on in the rest of the talk. Right, so let's first start with trustworthy AI, right? What does it mean to bring and build trusted and ethical AI using open source? So as we are all aware, right, we are living in an unprecedented time in the history at this point, right? We are in the midst of a global health crisis. Now, what you see is the COVID dashboard screenshot of which I picked, maybe a few weeks ago. And from IBM, right, we have a history of tech for social good, right? IBM had around like 4,000 engineers working and helping with the first moonshot, right? When the first couple of astronauts landed on the moon, there were around 4,000 IBM engineers working day in and day out, jointly along with this mission to actually help enable that. And then, over the course of time, IBM has had, multiple initiatives around, running gene sequencing, responding to infectious diseases, etc. And now of late, very recently, for the last few years, IBM has been leading, working with United Nations and Red Cross and other initiatives. The Call for Code Challenge, right, which focuses on different disasters, climate change, infectious diseases, etc. And carrying forward that tradition, right, we have also been working very responsibly to bring trust and transparency into AI. A lot of you will ask, right, does it really matter? Right, is it a nice to have? Should I be worried about it right now? I think it does, definitely. And in fact, I believe it does more so in these unprecedented times, right? Specifically during a crisis, you will see that, there are folks or in general, the society as such tends to ignore or, create biases, and the systems and the structure which evolves, right, it tends to be more biased towards a particular race, particular gender, etc. So I think it is more essential even during a crisis. And as we saw from our CEO Arvind last year, that essentially it's the time is now, as he mentioned, right, in his letter to the US Congress for June 2020, when IBM discontinued any use of facial recognition technology within its suite of products or internally within our solutions, right? We said we are not going to do this. We were the first company to actually make that declaration, and thereafter, many of the big other companies came forward and did something similar, right? The other reason is, right, if we fail to make ethical and inclusive artificial intelligence, right, we probably are going to shift back a lot of the progress we have made during the civil rights movement, during the gender equity movements, right? And that's where, ensuring the systems of AI which are built today, which will be there for the next, 5 to 10 years, they are built in an ethical and fair and in a manner, right, so that they can be trusted. Now, what is our vision for trusted AI, right? We have 4 pillars which we look at, right? So robustness, fairness, explainability, and lineage, right? Now, what do we mean by them, right? Can anybody tamper with it? Is it fair? Is it ethical? Is it easy to understand, right? And is it accountable? Can we trace back the whole lineage and the provenance when the time comes, when your models are making these life-changing decisions, right? And in terms of open source, we are leading these trusted AI initiatives with 3 open source projects around fairness, robustness, and explainability. And I will go into the details of some of these projects moving forward, right? So let's talk and begin with robustness, right? Can someone tamper with your AI? Now, as we are seeing, right, I mean, the adversarial attacks, ransomware attacks, they are becoming so commonplace, right? I mean, over the course of last year, we have seen, there have been numerous instances of, security attacks happening. Now, this is a very, very, trivial example. And when you start moving towards more real world use cases, you start seeing that, how it starts impacting in your day-to-day lives, right? So for example, in this case, when you're depositing a check, and if it can be adversarially impacted, so that the adversarially generated images undetectable in terms of the human eye to see any perturbation, but when a model sees it, instead of having a check of $153, right, it interprets it as a check of $753, right? So the bank credited $753, right? So you can see that how adversarial AI can be used in more business-centric scenarios, right, to go against you. But there are other cases where it can be even more scarier, right? So again, this is a bank example, right? So similar one where you can make a 4 look like a 7, for example, or a 9 in this case, right? So the original check was 461. Now the bank is thinking it's 961, right? So the AI models can be fooled. And when you start having these AI models make life-changing decisions for you, for example, in the context of a self-driving car, if it is supposed to stop at a stop sign and it doesn't stop because those images on which it was trained were adversarially perturbed, either intentionally or unintentionally because of the wear and tear, what you get is in a car which doesn't recognize the stop sign, it doesn't stop. Right. And things can get even more scarier, right, where you have people being uh, not in a safe zone when self-driving vehicles are there, right, because AI in this case, for example, is not able to detect pedestrians crossing a street. So there are different adversarial threats to AI which can be used, like for example evasion attacks, poisoning attacks. And evasion attacks are typically performed at the test time, right? Or when you're calling a model for prediction. And poisoning attacks are mostly at the training time, where adversary gets access to your training data and uses that backdoor later. To handle these, we launched a tool in open source called Adversarial Robustness Toolbox, or ART. It's a library dedicated to adversarial machine learning, right? It allows you to rapidly craft and analyze attacks, defense, and detection methods. There are different kinds of attacks, as I mentioned, evasion attacks, defense methods, etc. And it works across both machine learning and deep learning toolkits, right? Such as Keras, PyTorch, MXNet, which are listed there, but then scikit-learn, XGBoost, etc. Multiple algorithms which are implemented there for all these different evasion attacks. And if you do find your model vulnerable to adversarial attacks, using the evasion defenses, poisoning detection, etc. And essentially, if you go to this particular link, you can run a demo on your own to see, how this works at a very simple level. In this case, it's a very trivial example. For example, this is a Siamese cat, and a model is 92% confident that, this is a cat. Now, if we, insert a tag in this case, right, and we just run it at a medium level, we see that the model is now 19% confident that this is an ambulance, because the model has been fooled. Now, from a human eye perspective, the perturbed image is the same, right? We cannot see a difference, but it's easier to fool a model. Now, once you find a vulnerability, right, you can use one of the defense mechanisms which the tool provides, right? So in this case, for example, something like spatial smoothing, which is around essentially reducing the number of pixels so that the surface area of attack is much lesser, and then the model is back to its confidence level, right? So this is in general nutshell what the tool gives you. Now let's move to the next one and talk a bit about fairness, right? Now, what does fairness mean, right? So essentially, when you define bias, right, it's a systematic pattern of deviation from a norm or rationality in judgment, right? Now, we all as individuals create our own subjective social reality, right? Depending on what is fair or unfair, are we being biased or not, right? Now, let's take an example of bias in AI, right? And how it actually changed the life of many people, right? Now, since 2008, nearly every arrestee in Broward County in Florida has been assigned a risk score, right? Which actually used to determine their sentences, how long they should be sentenced, or they should be set free. Now, typically, defendants, and they were given a score. And if you get a low score, you are set free. Now, what this system did was, it falsely flagged Black defendants as future criminals, wrongly labeling them this way at almost twice the rate as white defendants, right? Now, as you can see in this example, for example, right, Vernon Prater and Brisha Borden, right? Brisha got a high risk score of 8, and Vernon got a low risk score of 3. Now, if you look at what they did, right, Brisha had previously just 4 misdemeanors, and she did nothing after that. But when you look at Vernon, right, he had 2 armed robberies, 1 attempted armed robbery before this score was assigned, and after that he actually did a grand theft, right? So how you see the system is biased, and there are examples after examples. In this case, for example, there were 2 drug possession alerts. As you see, Dylan is very low score, 3, Bernard very high score, 10. Now, if you see, what actually happened before, these scores were assigned, Dylan had attempted burglary, and Bernard was just resisting arrest without violence. And after that, he did none. Whereas when you look at, Dylan, he actually, had subsequent, 3 drug offenses. Similarly, this is a DUI case in which Mallory was assigned a medium risk score of 6. Gregory, on the other hand, is found to be, very low risk at 1. Now, what he had done previously, if you look at Gregory, he had 3 driving under the influence of alcohol, right? And after that, he did 1 domestic violence. Whereas, in case of Mallory, she just had 2 misdemeanors, and after that, she did nothing. So cases after cases of the systems, AI systems being biased, right? Now, one of the things, right, which we did when we were looking at, right, at this particular problem within IBM research, we created a hypothetical use case, right, where we designed a scenario in which, how racial bias can be prevalent in healthcare, right, and how it prioritizes certain patients over other patients, right? I mean, that was a hypothetical scenario. We created an example, we created a demo notebook, and lo and behold, a couple of years after that hypothetical example, there was a report in Wall Street Journal that, racial bias is actually really found in hospital algorithms, right? Black patients were less likely than white patients to get extra medical help. So I think if you look at, the brief history of fairness, until like 2016, it was mostly really, are we really going to be focusing on it? Is it really important? And all of a sudden, I think, 2017 onwards, it has become the topic of mainstream conversation. So from an IBM perspective, we have a tool which we launched called AI Fairness 360. It's an open source library, right, which helps detect bias. And if bias is found, it also helps you remove bias in machine learning models, right? So essentially, it has around 70 plus metrics on which it can detect bias. And if the bias is found, then, it has around 10 plus bias mitigation algorithms, which you can use to mitigate bias out of this. It works across the AI lifecycle. So as we call, pre-processing, classifier, in-processing, or, post-processing, you can use the algorithms present here in all the different parts of the lifecycle, whether you're working on the data and you want to point this to a data set to find bias, or, while you're training the model and you built your initial model, you want to look for bias in that, or even after, once you have deployed your model, right? So gives you algorithms to work across that. As I mentioned, there are, 70 plus metrics. If you do want, to go into the details of it, definitely hit me after the talk, send me an email, or, go to the website, which I had listed initially, and you will find detailed explanation of all these different metrics on which you can evaluate bias. And then, the algorithms to mitigate bias, right? There are different 10 algorithms at this point, which are available. Some of them are conceptually easier to understand, something like reweighing, where if bias is found on your data set, right, you essentially, go and give different weights while you're running the training so that, the bias is mitigated while running the training, right? So, and then there are other techniques available as well. Now, where can I find this example and the details about the metrics and the algorithm? So hit this particular website, aif360.myblomex.net, and you would be able to find all the examples. And if I have time later, I can walk you through a demo as well. Okay, so we talked about robustness, fairness, and let's talk a bit about explainability. Right now, when we talk about explainability, I think this is probably the more adopted a concept of late, where we are seeing more and more enterprises getting into it. So at this particular point in time, like there are different audience for explainability, right? So one is the end user and the consumer who is actually getting impacted by a model decision, right? So hey, if a model is telling that you need this particular treatment, why do I need it? Why was my loan denied? Right? Why am I being denied university to admission to this university? Why is my resume not being accepted? Right? So you need answers if AI systems are making these life-changing decisions for you. Then there are government regulators, right? The compliance and the audit folks who want to make sure that for each individual transaction, but also over a period of time, these models are doing things which are consistent, can be regulated, and have generated explanations in terms of why they are doing what they are doing over a period of time, right, consistently. And the last but not the least, the developers as well, right? I mean, a lot of the times now, you're getting black box models, right, which are required to further train, right, and having explainability, which can explain, what that black box model is. is very important for developers to continue further on that cycle. So AI Explainability 360 is a toolkit, again in open source, which focuses on this problem, and it generates explanations across the AI lifecycle, what we call local post hoc, global post hoc, and directly interpretable explanations. So if you look at typically how does it interpret? So you can actually point this to a data set, right, and it can then generate explanations around a whole case of samples or a set of features, right? If you can point it to a model, right, it can then look at model, if it is a model which can be now when you're looking at a model and pointing this toolkit, right, you can look at it in the context of a local explanation, which is essentially explain an individual transaction. Now when you're explaining an individual transaction, right, you can use algorithms from this, or you can use it in the context of a global explanation, which is essentially explain the whole model, right? And then there are techniques, right, which you can use, whether if the model is directly interpretable, which means it's not a black box model, you can actually read and understand. And in some cases, if it is a black box model, then we use something like post hoc explanation, which is essentially built on top of a black box models to provide global understanding, right? And if you follow the simple use case flow diagram in terms of which algorithm to use when, the tool walks you through it. So as you can see in the context of, right, when you look at local direct explanation, it's mostly straightforward. The model, if the model itself is understandable, then you can generate fairly well explanations, right? Or if you're training a black box model, then you can have explanations generated out of that, right? But in a lot of cases, folks actually produce an interpretable model in parallel to a black box model, right, which can provide explanations. So you're essentially having a surrogate model which is learning on explanations provided by the black box model and training itself and creating further explanations, right? So that's another technique which is used, right? So a lot of these techniques are available as part of the Explainability 360. Again, please reach out to me for more details. There is a demo available on this particular website, which is called aix360.mybluemix.net, plus details about the algorithms, etc., which are provided. So again, to wrap up the scalable AI section, right, as you can see, IBM has a holistic approach towards ethical AI, right? We work at it from an open source angle, where a lot of the open source toolkits which we are launching, we're working with Linux Foundation AI, we are embedding it in our products like Wotson OpenScale, Cloud Pack for Data. Then we are doing publications in top AI venues. We are filing patents around it. We have received numerous awards around trusted and ethical AI. And then we are working with external groups like European Commission with high level group on UI, USAI caucus, National Institute of Standards and Technology, World Economic Forum, right? So we are working at various levels at this particular set of problem. We essentially, when you look at it from an open source angle, IBM joined Linux Foundation AI and data, and we donated all these trusted AI projects we talked about into this, right? And these projects are now part of Linux Foundation AI Trusted AI Committee. And then, I am the North America chair for this, right? But we have representation from across the globe, from different companies who are participating in this and defining both the principles as well as the technologies to solve trusted AI related problems. Okay, as I mentioned, the 3 projects, and there are principles which are being defined as part of the Linux Foundation AI Trusted AI Committee. So I strongly encourage all of you to come and join us and define the space, right? I feel passionately about it, and I hope you feel as much a passion about this field as I do in terms of advancing these techniques. So now, since we have now talked about the first big part of the problem, right, which is building trusted and ethical AI, let's talk about like how to scale this AI for your enterprise, right? So if you look at the basic AI workflow, right, you're essentially using data to build models which are automating decisions, right? I mean, any AI problem can be figured or can be boxed into these three areas, right? Whether you're working on the data or you're building models, or you are essentially embedding AI into your applications. Now, If you expand that workflow, there is a lot going on each of these fields, right? So when you're looking at, when you're using data, what are you doing there, right? You're doing data cleaning, ingestion, transformation, data validation, feature engineering. When you're building a model, right, you're building training, running hyperparameter optimization, training at scale. Then, when you're going to deploy and consume it, right, you're deploying it and then scaling it. Then you're engaging and adding monitoring and logging and explainability and drift and bias. Then you are continuously repeating this cycle again and again, right? So the AI life cycle is very expansive. Now, if you look at the typical neural network design workflow, right? You start with the simple base neural network or a model, and then you assign some hyperparameters and you run the experiment, and if the performance meets the needs, no, okay, then we tune the hyperparameters, we start another experiment. If it meets, then you actually go to cloud and deploy. And then once you have deployed, your task is not finished, right? Unlike in case of applications, because models will be changing, right? So you want to evaluate, and if the decisions are fixed, according to certain criteria, you're good. Otherwise, if they're bad, you will need to start another experiment all over again, right? So if you can see, right, AI in general and deep learning in particular are very, very iterative and repetitive, right? And they need cloud. Why? So essentially, to scale AI, you require the strength of HPC and GPUs, right? So right now within enterprises, you're not given that freedom or liberty, right? Hey, run this training for 4 weeks, right? You are supposed to be running training within 4 hours at the most. Right. I mean, that's the expectation which is coming on top of enterprises these days, that models need to be produced in high quality. So you need to be able to use the strength of HPCs and GPUs. Right. And the secondly, we need ability to scale AI workloads on demand. What that means is that we need to run it on cloud. Now, to scale these AI workloads on demand and run it on cloud, right? Typically, I believe most of us have standardized on Kubernetes as the cloud operating system, right? So that means if you need to do end-to-end AI on Kubernetes, you can become an expert in containers, packaging, Kubernetes service endpoints, persistent volume scalability, immutable deployments, etc. Or we can use something like Kubeflow, which is an end-to-end machine learning platform, right? Which essentially allows you to automate this whole end-to-end AI lifecycle on top of Kubernetes, right? So you'll build, train, validate, deploy, manage, monitor everything being done on top of Kubernetes, and Kubeflow comes with a package solution around all these areas, right? So let me go into some of these, right? How does and what are some of the technologies which are available here for you to be able to run and scale AI on top of Kubernetes, leveraging the underlying the containerization scalability principles of the cloud. Right now, before that, in general, IBM is the second largest contributor to Kubeflow, and there are other companies, right? A lot of other companies which are contributing. The project was initially initiated by Google, but then you have the likes of Cisco, Amazon, Selden, Ericho, Huawei, NVIDIA, etc. Coming and joining the mission and contributing and growing it, right? So let's talk about AI lifecycle, which and the build part of AI lifecycle, right? So as I mentioned, we have build, then we have the deploy, and then we have the manage, right? So in the build part, you are essentially creating that initial model, running trainings, hyperparameter optimization. So Kubeflow provides Kubeflow Jupyter notebooks, which are essentially Jupyter notebooks launched on top of Kubernetes clusters, which essentially give you stronger ability to configure your own CPU and GPU and memory for your notebooks, as well as leverage the persistent volume claims, etc., which are running under the Kubernetes, right? So that's essentially the model. Now, you can go to the Kubeflow console, and there is a lot of security and isolation built in. So you can, and it's using the paradigm of Kubernetes world, it's using the namespace under the covers, right? So you can select a namespace, launch a Kubernetes notebook, and start it, right? And once you connect to it, it's exactly the same experience as you run Jupyter notebooks on your laptop or on some other cloud provider's solution, right? So one of the things which you can configure while you're launching these notebooks, as I mentioned, was CPU, memory, whether you want a GPU to run this, right? Do you want a persistent volume claim under the covers, right? So a lot of these things, fine-grained capabilities are now available in Qflow to launch a Jupyter notebooks. Okay, so that covers, the build part of the life cycle. Now, the second thing which you want to do in terms of scaling is running distributed training, right? And the reason you want to run distributed training is because if you're just running training on your laptop, yes, you can get it done, but you'll get it done in 3 weeks. And if that's not what you want to do, and if you want to get it done in 3 hours, right, I mean, you will have to distribute it, right? And there are different distributed training operators which are available in Qflow out of the box to run distributed training on top of Kubernetes, right? So for TensorFlow, PyTorch, right? And if you're running it across multiple machines, right, where you want to even further optimize using the MPI protocol, right, so that the communication on GPUs across multiple machines is even much faster, then you can use something like the Horoward protocol, right, which came out of Uber. So as I mentioned, not only the deep learning operators, right, but also the machine learning operators are available. So, you have XGBoost and others. One of the things which I do want to highlight is also operators like Chainer, right? So Chainer is something which is pretty popular in Japan, right? So if you go to Japan, you see Chainer being used more, right? So all these different kind of operators are available by default to run distributed training on top of Kubernetes, right? With different algorithms. As I mentioned, right? If you're using TensorFlow, you can use TensorFlow's parameter server approach to run distributed training, which essentially is syncing weights and gradients across the different parameter servers. Or you can use the Uber Horoward's MPI mechanism, which is essentially, syncing weights and gradients in a more peer-to-peer fashion, right? And it optimizes your communication across multiple machines. Okay, so you can build your models using Qflow Jupyter notebooks. You can run distributed training using different distributed training operators. And then, you can bring more automation using hyperparameter optimization and neural architecture search, right? So the Qflow project, which goes into this space, is called CATIB. There are different hyperparameter tuning algorithms available, like random search, grid search, hyperband, and then, different neural architecture search algorithms available, right? So the way this works is, essentially you can choose the type of experiment you want to launch, and then, define the hyperparameters, define your objectives, right? What do you want to optimize for, right? What are the metrics? And then, what are the different hyperparameters? And then you launch one experiment, right? Now, once you launch the experiment and it is running, you can then go and monitor the progress of that experiment, like in terms of, how are the different, hyperparameters performing, and which are the best parameters which are going to take you towards the optimization you need, right? So in this case, for example, we want to optimize for learning rate, right? And minimize the loss rate, right? So then you look at, the different experiments running, and it gives you what will work in this case. Okay, so we talked about we talked about how to build your models, how to run distributed training, and how to run hyperparameter optimization. Now let's talk about, okay, you have your models ready. How do you deploy them in production, right? And what are the problems there, right? Now, this is in a nutshell, the end phase of your AI life cycle, right? You are essentially now, this is the time when the rubber is meeting the road. You have spent all your time on the previous phases of the life cycle, on the data side, on the ML side, and this is the final outcome. Now, when you look at it, right, there are different things which you want to optimize for, right? Given the models are very resource hungry, right? Is the model over or under scale, right? Can I roll out new versions of the model, right? And do candidate testing, right? How can I support different protocols like gRPC, HTTP, etc., right? How do I support different frameworks like TensorFlow, XGBoost, Scikit-learn, right? How do I explain the predictions, right? How do I detect outliers, etc.? So a lot of the problems which need to be solved when you're modeling and deploying models in production. So for that, we have a project in Qflow called KEF Serving, right? It was initially founded by Google, Sheldon, IBM, Bloomberg, and Microsoft jointly. And we have focused extensively on 80% of the use cases to provide you serverless machine learning inferencing. So that means, if you're not getting traffic, your models are not going to occupy your expensive GPUs, and they can be totally scaled back to zero. So that means, they are not utilizing any infrastructure. You can do canary rollouts. So essentially, you can roll out new versions of the models. You can generate explanations, and you can also plug in your own pre-processor and post-processor into these, right? So let me explain a bit more around something like canary, for example, means since you're creating new revisions of the models again and again and again, right, and launching new versions, given the repetitive nature, you know you can essentially just for example, use KF serving to launch a canary version and specify how much traffic percentage do you want to send to the next revision of the model. And then, different kind of model servers are supported, as I mentioned, right? TensorFlow, NVIDIA's TensorRT, PyTorch, XGBoost, and different kind of backend storage mechanisms like AWS, S3 storage, GCS, persistent volume claims if you're running in an on-prem fashion. Now, the scaling part, right, whether it's scale back to zero or scale up these models, right, comes by leveraging the in-flight metrics, right? So based on the number of in-flight requests for prediction against your models, we use that particular means as to auto scale. So there is an activator which buffers all these different requests, and then there is an auto scaler, right, which takes and reads the matrix from the activator, and then auto scales your models, right, from 0 to n replicas, or back to 0 if needed. Now for canary, right, we use under the covers some of these two capabilities to actually control and route traffic. So in this case, for example, if you're launching a canary version of the model, you can selectively specify how much traffic you want to send to that canary version, unless you're satisfied that this model is ready and to be moved as the default, and that's the primary. Okay, so we talked about different parts of the AI lifecycle. How to build, how to run distributed training, how to do hyperparameter optimization, and then how to deploy your models in production. Right now, how do you bring all these things together, right? So Qflow has a project called Pipelines, right? Qflow Pipelines, which essentially allows you to automate all these things and run them in a repetitive fashion so that you can scale, your AI deployments, right? Now, to cater to the data scientist and make it very easy for data scientists to define these pipelines, Qflow pipeline provides a Python DSL, so you can construct your pipelines using Python. And then using that Python, it exposes a lot of the underlying Kubernetes constructs like volumes, secrets, etc. And each of the steps of that particular pipeline and functions translate to a container running on top of Kubernetes cluster. Now, in this case, you see like this is around 15 to 16 lines of Python code, but it is doing, TensorFlow data validation. It's doing pre-processing. It's running distributed training using TensorFlow's distributed training mechanism. Then it is, using doing model analysis, and then finally deploying the model, right? So the whole AI lifecycle being done here by 14 to 15 lines of Python code, right? Isn't that great? That's the power of automation, which you can leverage and then start scaling up your AI workloads, right? And while it is running, right, you can visualize the state of various components, like and create things like ROC curves and other things. It automatically versions the different pipelines for you, right? And then creates and generates different artifacts, right? So for example, a modified version of the data set, a model which is produced, all these artifacts are stored and created for you to go later and look at the properties of them. Not only this, it gives you the total lineage tracking capability. So essentially, after running that experiment, once you have created that model, you can trace back all the way back, right, in terms of, what were the data set used to train that model, what were the hyperparameters used, what was the version of TensorFlow used, how was the modified schema for the data set. Every single thing you can trace back using the dashboard. This is a high-level architecture, right? And for the purpose of time, let me do a time check. Yeah, I would not go too much into the deep details of this, but under the covers, it uses by default an Argo workflow engine, and then All the kubeflow capabilities come on top of it. There is another metadata store called MLMD. And then, on top of it, you have the Python SDK, the UX, and Jupyter Notebooks integration, etc. Now, as I mentioned, right, you can use these pipelines to start automating and scaling up your AI workloads, right? So you can use them to run the whole AI lifecycle, like training and deploying your models, and then even go further and start launching more advanced monitoring parts, right? So in this case, you can train, deploy, then launch, and send some scoring requests to your models, and then have some post-processing techniques which are embedded in there. The other part is like, we have open sourced a project from IBM called Elira, which allows you to drag, drop, and create these, different techniques, right? So essentially, you can drag and drop and create these pipelines by combining various notebooks or different components moving forward. So you don't, if you don't want to use Python DSL, right? And then we have built a product within IBM called Wotson AI Pipelines, right, which is built on top of it. But then under the covers, right, we have leveraged Kubeflow pipelines and rewrote it to actually work with Tekton instead of using the default Argo engine, right? We have strategically invested in Tekton, which is the underlying CI/CD engine in OpenShift, as well as IBM Cloud, and it made sense, to rewrite Kubeflow pipeline or machine learning and AI pipelines universe on top of that underlying engine. Right, and essentially from an end user perspective, there is no difference, right? You essentially get the same Kubeflow pipeline experience, which means you're getting the same logs. You are able to use so stream logs in real time while the pipeline is running. You are able to do lineage tracking, right? So you can look at, for example, the different artifacts which are produced, and then track the lineage of those artifacts all the way back, how the process started. So all those capabilities which you use are available by default as part of this as well. And then you can run all the different end-to-end Kubeflow components which are available in the community, which I showed today, using the Kubeflow pipelines and Tekton version. Okay, and building on top of it, we have very recently launched a project in open source called Machine Learning Exchange, which is a data and AI assets catalog and execution engine, which essentially allows you to register different AI assets. And as part of that registration, it gives you some common services which you can use, right? Some common services to run training on your registered models, or download your data sets, or run pipelines. All right, so all this is pre-integrated as part of this engine. So definitely go and try it out, give us our feedback on this particular one. And as I mentioned, like the heart of it is the common metadata. So when you registered, for example, a model with a common metadata schema which we have defined, we know that okay, this model needs to be deployed, and we can give you some common services, right, to deploy these models as part of this. Okay, so we talked about trustworthy AI, and we talked about how to scale that AI for your enterprise, right? So a lot of the projects in trustworthy AI, like AI Fairness 360, AI Explainability 360, Adversarial Robustness Toolbox, which we created and donated to Linux Foundation AI, as well as how to scale using an open source project like Kubeflow and Jupyter and others, right, to actually scale up your AI workloads. And how these two things can work together, right, is essentially what we have been doing. Essentially, we have been integrating trusted AI with Kubeflow pipelines, right? So we have created components, default components for things like fairness check and robustness check. So if you're running pipelines, you can then insert these components. For example, after running your distributed training, if you want to evaluate the models, whether it's adversarial, whether it's vulnerable to adversarial attacks, is it robust enough, or if the model is going to produce unbiased and fair results, you can insert these components for these projects into your pipelines and use it, right? So you can scale up using that. Or if your models are deployed in production, right, we have integrated these toolkits, right? So you can now, for the models deployed in production, you can monitor things like whether the model is producing fair results, if the model is generating explanations, is the deployed model vulnerable to adversarial attacks, etc. And to do that, right, behind the scenes, we use a technology called payload logging, right? So payload logging is essentially, we are collecting all the different requests and responses coming to your models in a standard format, a cloud events format, which is a standard from CNCF, right? So once we log all these different, requests and responses, then we are able to run more advanced analysis on top of these, like, to do bias detection, adversarial detection, to do outlier detection, to do anomaly detection. All these technologies are now, integrated as part of, KF serving, which is a production model serving deployment platform, right? And then you can automate even further, right? So you can then automate all these things in a single pipeline. So in this case, if you see a pipeline, it's not only deploying a model on KF serving, but then, deploying different kinds of detectors, outliers detectors, drift detectors, anomaly detectors, right? And testing models. So you can automate this whole thing. You can test an explainer, all these things using, these pipelines, right? So that's where, we are bringing these two worlds together, where we are building and integrating, ethical and trusted AI projects, which are now part of Linux Foundation AI, and scaling them using a technology like Kubeflow pipelines, KF serving, and others. So with that, I would say thank you, and thanks for sharing the talk, and hopefully, you get excited about these projects as much as I am. And if you do need, any questions, right, definitely reach out to me at this email address. Let me correct the yes. So this is the correct email address if you're reaching out on Gmail, or otherwise reach out to my IBM address. And thanks. And if there are any questions, I will be able to take it from here. Thank you.